Is everyone there? Keep your videos on. Have you all returned?
Yes, sir.
So in the previous class, we talked about the properties of water. We understood the water cycle. We understood how water is a compound. We saw the physical properties, the effect of impurities in water on the freezing point, on the boiling point. We understood what is specific heat, right? And we saw that because of the specific heat, which is high in water, it is used as for different purposes, especially like in cooling the engines or as a coolant. Okay. We also studied about the anomalous expansion of water. Can anybody tell me what exactly does it mean by anomalous expansion? Siddhant Singhal, can you try?
So could you repeat? Your voice is lagging.
I told you in the previous classes, there is a property of water in which water is an exception to the rule of density and temperature relation. It's called the
Yes.
anomalous expansion or the anomalous property of water. What exactly is it?
Sir, the anomalous expansion of water is like when water is heated from 0 to 4 degrees Celsius, it contracts, and on heating above 4 degrees Celsius, it expands.
So what does it happens when it contracts?
Uh,
So what does contraction do? It's a good thing it contracts. It takes up less space. Good for it. Right? But what does it do? So you see, this is where you lose a mark. If you don't relate it to the entire concept, the main concept of anomalous expansion. Remember, temperature, do we talk of contraction or do we talk of something else? Mahuri, can you try? What is the term which he should have used? Mahuri, you were not audible. Density?
The density increases.
Right. So it's a density there, right? So if you look at the, let me show you a figure regarding this. Okay. So if you see the volume and the density chart at 4 degrees Celsius, so if we go increasing the temperature from 0 to 4 degrees, you will find that the volume of water is decreasing. So the volume decreases, but the density increases. This is from 0 to 4. So at 4 degrees Celsius, water has the maximum density and the least volume, because you also know that density is mass upon volume, right? Heating further from 4 degrees onwards, we will find that the volume is rising here. So initially what was happening? Initially the volume, when we went from 0 to 4, the volume was decreasing. From 0 to 4, from 4 onwards, the volume increases. From 0 to 4, the density increases, and then it falls rapidly and becomes low. Is this clear? So this is the property of anomalous expansion of water. Okay. Now, related to this concept, we have ice and water. Okay. Ice is lighter than liquid, than water. You already know. Yes or no?
Yes, sir.
Why is that?
So the density of ice is slightly less than that of water.
Yeah. So what will it will happen because of that?
So it will float in water.
Yeah, it floats in water, it becomes lighter, right? So ice is less dense at water. So you see over here itself, this is the chart which can explain to them. Okay. So again, When a substance is heated, it expands and its density decreases. And when it is cooled, it contracts and the density increases. But water shows anomalous behavior in which it expands, its volume decreases as it goes from 0 to 4 degrees, so that the density increases. And 4 degrees onwards, on heating it further, it volume increases and density decreases, right? And we already studied about this. The density of water at 4 degrees Celsius is 1 gram per centimeter cubed or 1000 kilogram per meter cubed. These figures or these numericals should be learned. Okay. Where is this example used? One important example this is used in nature is freezing of lakes. You must have seen in a lot of movies that the people, they walk on the lakes and they dig a hole and there is water underneath. Can anybody try to explain why does happen? Can anybody try? Same thing, anomalous. Try it with the anomalous expansion of water. No one? Okay. All of you will just copy this down, make this chart in your books also if you want, or in your notebooks. These are very important charts. I'll quickly explain also once. I'll give you a couple of minutes to copy this down and I'll explain to you why freezing of lakes is used as an important property of anomalous expansion of water. Okay, done everyone?
Yes, sir.
Okay, now look over here. So let's say we have a lake and this is nice and warm. So the lake has full of water. Okay. And we have a few fish which are floating inside swimming inside the water. Winter comes and the temperature drops to 0 degrees outside or even less than 0. Okay. So it will become even less than 0 degrees Celsius. So what happens now? When the temperature falls, the water of the surface of the lake initially cools. So this surface water will cool down, right? And this water, what happened when it will cool? It will contract. Okay. Now what happens is the heavier, colder water will sink. So this cold water will go down and the heavier water or the higher temperature will go up again. This will continue until the water reaches 4 degrees Celsius throughout. Okay. Now what will happen is that because of anomalous expansion of water, as the temperature goes below 4 degrees Celsius, what will happen to the water? Come on, tell me.
Sir, can you repeat?
Is this part clear? Like supposing this water temperature was 20 degrees Celsius earlier, as the temperature outside grew colder, the temperature fell down to 4 degrees Celsius. Okay, so let's say the surface temperature first fell to 10 degrees Celsius. It becomes lighter, so it sinks. It contracts, becomes denser, so it sinks. And the warm water rushes up to take its place. Is this part clear, everyone? This will
Yes, sir.
continue. This will continue till the water reaches 4 degrees Celsius. Isn't it? Because we know that, let me show you the graph again. when we decrease the temperature till 4 degrees, there's an increase in density. So as the density increases, the object is contracting and it will become heavier, isn't it? So the heavier water is sinking down and the lighter water is going up to take its place till it reaches 4 degrees Celsius. Is everyone clear on this? There are two parts to this question. First is reaching 4 degrees throughout the lake. Mahuri, Sarah, Vastani, Sia, Siddhant, Suramya, is this part clear? How the entire lake became 4 degrees. Is this part clear till now?
Yes, sir.
Only Parth is there in the class, nobody else is present. Suramya said yes, Sia said yes. Siddhant, Sarah Vastani, Sarah Patil, Mahuri.
Yes, sir.
Mahuri, yes. Sarah Patil, Sarah Vastani. Unmute yourself, Sarah Vastani.
Yes, sir.
If any concept is not clear, you have to open up and tell me it's not clear. How do I assume that you know this? When I'm asking you all, is it clear? If you don't reply back, how will I know that you don't understand? Okay. Tell me, the temperature outside is nice and warm and the temperature of the water inside is 20 degrees. Is this part clear?
Yes.
Now let's say that winter is approached and it's winter already and the water and the temperature outside falls to 0 degrees or even lower than 0 degrees. So what will happen to this water on the surface? What temperature is the water at right now?
The water is at 20 degrees.
So what will happen to the surface temperature? Temperature of which water will change fast? The surface water or the water deep inside the lake?
The surface water.
So this surface water will start cooling. So this surface water, let's say it becomes now 15 degrees. Yes. As we decrease the temperature, what happens to water? It contracts,
Increases.
its density
Yes.
increases. So this density will increase, volume will decrease, right? It'll become
Yes.
heavier. So this water will start sinking down.
Okay.
Yes or no?
Yes.
And this water at 20 degrees takes its place. Correct? So now
Yes.
water down is 15 degrees and on top is 20 degrees. Then this 20-degree water will also reach 15 degrees. Then this circle will continue and all the water reaches 4 degrees. So then this will become 10 degrees, then it will become 6 degrees. And ultimately, the entire water will become 20 degrees. Is it so far clear?
Yes.
Because the heavier the water, till 4 degrees, the water becomes heavier. It becomes more dense. It will sink, right? So now what happened is that the entire water is at 4 degrees Celsius. Clear so far?
Yes.
Now what will happen at 4 degrees? So even the surface water is at 4 degrees now. Now what happens at the surface water cools further? Let's say now the surface water becomes 0, let's say becomes 1 degree. Falling from 4 to 1 degree, what happens to density?
Density will
So water will expand and the density will decrease.
Water expands and density decreases. Yes, Sarah?
Yes.
So what will happen? Will the water at top become heavier or will it be lighter when the density decreases?
If the density decreases, it will be lighter.
So it will continue to stay up. It will not sink now. Okay.
Yes.
So what will happen? Only the temperature at the surface now is going to start falling to 0 degrees. Once it reaches 0 degrees, this top surface will turn into ice. Right? But the bottom layer will remain at 4 degrees Celsius. Clear?
Yes.
Now what will happen is this layer of ice also acts like an insulator, which prevents the further temperature from reaching into the entire lake. And you also know that water is not a good conductor of thermal, is not a good thermal conductor, so that it stays in that place, right? Okay. So what happens is because ice is a poor conductor, because it's not pure water. Ice, has impurities in it also. So it is a poor conductor of heat. So it acts like an insulator or a blanket which prevents the cold from going down. Otherwise, what will happen? Gradually, this entire lake would freeze over. But that doesn't happen because this insulator. Ice being a bad conductor of heat, it acts as an insulator and prevents the lower temperatures from coming and freezing the entire lake. So that is why these fish, they can remain alive even though it is very cold outside and the top layer has frozen over. Had this property of anomalous expansion not been there, what would happen to the water? This entire circle would keep continuing and ultimately the entire lake would become 0 degrees and it could freeze. Yes or no?
Yes.
And all the life form in it, everything would die off. So there are two parts. One is the temperature of the lake falling from a higher degree, still 4 degrees, in which the entire, a circle continues, and the top water becomes denser, it sinks, and the lower water goes up until the entire lake is at 4 degrees. Now at 4 degrees, what happens is the reverse process comes. The water becomes more denser, less dense, and increases the volume. It becomes lighter and it floats on the water, and the lower water stays at 4 degrees. The upper layer then continues falling down in temperature till it becomes 0 degrees and it freezes over. Furthermore, this freezing does not continue throughout the lake. Why? Because the ice itself acts like a insulator or a blanket which protects the bottom layers from the cold air above. Right? So what will happen is, as the winter progresses or as it becomes colder and colder, only the top layer of ice becomes thicker, but the entire water does not freeze over. Okay. Everyone, please copy this down, write this down in your own words. From both, there are two parts. Part one, it is from, let's say, 20 degrees Celsius falling till 4 degrees Celsius, what happens in the lake. And part two is 4 degrees Celsius to 0 degrees Celsius, what happens. Both parts, explain it in your own words and quickly let me know once you're done. This is a very, very important concept. Please learn this. Learn to write it down in your own words. If you want, I'll give you the explanation also in detail so that you can compare your explanation given with the main keywords which are here. So this is called the anomalous expansion of water. Okay, you can read it and see if your keywords are there. No, it's not very fast part. It's a continuous process and the water color is the same, right? So that's why that circle current is not shown, seen. But yes, if you go down, you may be able to feel it.
Okay, sir.
We cannot see it because the color of the water is the same.
Yes, sir.
Okay. Done, everyone? One question. Sometimes in colder parts of the world, the water pipes, they burst in the winters. Why is that? Why do water pipes sometimes burst in winters? It becomes very, where it becomes very cold. Think about it. I have a pipe which is carrying water. It becomes very cold outside. What I'll notice is that the pipes will burst. Let's say the outside temperature is at 0 degrees, or let's say it's minus 5 degrees now. Pressure increase, Sarah Vastani, what kind of pressure increase? Sarah, unmute yourself. Which pressure are you talking about? The pressure of the water?
No, if the outside pressure increases, the pipe will burst.
Which outside pressure? There is no pressure on the pipe. It just become cold. There is no pressure other than the water flowing inside the pipe. Siddhant, try. Parth,
Yes, sir. I am also thinking only.
Sir, am I audible?
yes, Mahuri.
Can I try this one?
Sure.
The pipes burst because when the temperature is lower, the density increases. But water shows,
Temperature is lower
however,
than,
what
so wait. The temperature is lower than what? Firstly, which,
density increases.
which part are you talking about? Lower than what? Remember, there are two parts to water. One is density, the temperature decreasing till 4 degrees, and then second part is density decreasing from 4 degrees to 0 degrees. Which part are you talking about?
No, I'm talking about overall. Then I'll come to water.
Okay, fine.
But water shows anomalous expansion.
Hmm.
So density. So when it's really cold outside, like from 0 to 4 degrees, the density of water is
No,
at maximum, and hence the
0 to
pipe
4
cannot
degrees. The
withstand.
water inside the pipe was, let's say, at 4 degrees. So then what happens? It's still becoming colder. It's become minus 5 degrees now. So what happened? You're correct. You're going correctly, but just rework your answer and word it correctly.
Uh,
Okay. So initially the water inside was at 10 degrees. Okay. Temperature outside became less. So the water entire cold, the circle of water, the cycle of water felt, and then water reached at 4 degrees now. Now it's still colder. What will happen? Same thing what we did earlier. Did you all understand how it reached 4 degrees? Let's say from 15 degrees Celsius, the water was at 15 degrees, the entire water became 4 degrees. Is this part clear, everyone? Mahuri, is it clear? Siddhant, Parth, Sarah, Sia?
So can you just repeat the process, how it happens?
The same reason, on cooling the water from a higher temperature till 4 degrees, the density increases, the water sinks inside and the cycle forms, right?
Yes, sir.
So the entire
Yes,
water
sir.
will reach 4 degrees. Same thing what we did in the river, in the lake question. Now what happens when the water reaches at 4 degrees? It will fall further. The temperature has to fall further to 0 degrees because it's already at -5 degrees. So what will happen to the surface,
It will start expand. It will start to expand.
right? This part of water which is in contact with the pipe will become very cold and it will become ice. Isn't it? But problem is, where will the ice expand? Because ice takes up more space. Ice is basically increase in volume compared to water at 4 degrees. So how will this volume increase? The entire pipe is packed full of water at 4 degrees Celsius. So how will this increase in volume be taken into consideration? There is no place for it to expand. So what it does, it puts a lot of pressure on the pipes inside. So there is a pressure of the freezing ice on the pipes from within, and because of this pressure is so high that it cracks the pipe and it breaks through. Did you understand? This is because of which the pipe basically bursts. Because the
Yes, sir.
internal water, once it reaches 4 degrees, its further decrease in temperature raises the volume, decreases the density. The water starts expanding and turns into ice, starts turning into ice, but there is no space for the water to expand because the entire pipe is filled with water. So because of this, the huge pressure is exerted from the inside of the pipe, and the pipe bursts. Okay, is that clear? Same concept, just a little bit of difference in which here the ice is being formed, so the water is expanding. Okay, these two diagrams, just remember them so that there'll be no confusion with you. Volume and temperature, it will look like this, right? When you're doing volume, it looks like a V. So remember, this is a V kind of a shape. So it's V. And density and temperature, it's the reverse. It's like this. So you'll remember that. This is the highest is at the 4 degree mark. Remember, volume and temperature is V, density will be the inverse one. Please copy the explanation for the pipe bursting also. I'll give you a brief explanation. You can do it in detail depending on how many marks it is. If it is a 1 mark question, do it in depth, in brief. If it's a 3 mark question, explain anomalous expansion also. The same thing is there even for rock bursting. There are cracks in rocks which are filled with water. When it becomes very cold outside, the water starts expanding, but there is no place to expand, so that it pushes on the rocks, and even sometimes the rocks crash because of the immense pressure exerted by the rocks, by the freezing water. Please copy this down. Even a lot of plants, sometimes they burst because of this same thing, concept. Because as it becomes colder and colder, the capillaries, they're carrying water, they have no place to go, and the plant nerves or the capillaries also, they can burst and cause death to the plants. Please copy these notes down. Sarah understood. Sarah Bastani, did you understand now which pressure is it? Is the pressure of the freezing water inside the pipe now, right? Please copy this down, everyone. These notes are important. Okay. How are your preparation for your physics recaps tomorrow? Force and pressure and energy, right?
Yes, sir.
How are your preparations? Are you all prepared? Any doubts, any queries, anything?
Sir, I'm done with one chapter. I have to do the other one now.
What about the rest of you? Mahuri, Sara Patil, Sara Vastani, Sia, Siddhant, Suramya? Numericals, remember the formulas, remember the SI units. First thing you need to note is if there any conversions are required. Remember that. Okay, that's a usual place where you all trip and make a mistake. They will give you a unit which is not the SI unit, and then you will fail there. So whenever you have a numerical, remember the formula, remember the SI unit of the formula, and convert everything to the SI or the CGS unit as the case may be. Okay. Second thing you need to remember is the definitions. Learn the definitions carefully. We've been through them in detail. Third thing, in the chapter of energy, remember how work, energy, and power, all three are related together. When is work said to be done? What do we mean when I say energy? Is the capacity of doing work. When I say power, it is the rate of doing work. So whenever we do rate, a time comes into play. Think of the units and remember that, right? Any other doubts in these chapters? Pressure you already know. Force upon area, what are the factors which affect pressure then? Again, you will get if they ask you the factors, get it directly from the formula, right? Any other doubts, anyone? Force, pressure,
No, sir.
energy, kinetic energy. Remember the formula. So if they give you that the velocity is doubled or velocity is half, what is the effect on kinetic energy? You can answer those kind of questions easily. So keep your concepts clear, keep the definitions clear. Okay, that's it for today. I'll see you all again tomorrow. We'll be continuing at water, right? All the best for your recap tomorrow. Bye. Bye, everyone.